Hi everyone, today we are starting chapter 8, and this chapter is all about the quadratic function. Today's lesson is just going to be an intro to quadratic functions. We're going to learn some vocab. We're going to take a look at what this function looks like. And we're just overall going to talk about the key characteristics of the quadratic function. So just to remind you about what functions actually are in math, we've covered two major functions so far in this class. We spent a lot of time on the linear function, which looks something like this, y equals mx plus b. You all are very familiar with this equation. M means slope and b means the y-intercept. Sometimes we can also write functions in function notation, and you're going to see that in this chapter as well. So we can also write, instead of y, we can write it as f of x equals. And again, the linear equation just makes a straight line. It's got that constant rate of change, right? So we spent a lot of time on this in the beginning of the year. We also learned about the exponential function, which looks something like this. So it's going to have the x as an exponent, and it's got a base, and then this first number was the y-intercept. And the graph of an exponential function looks something like this. It starts off really small and then it starts to grow super fast. And that's because exponential functions are a repeated pattern of multiplication, while linear functions are a pattern of constant addition or subtraction. So today we're going to talk about a completely new function, and it is called the quadratic function. Now it's going to look kind of familiar. The equations are going to be quadratic. That's a term that we learned in the last chapter. Quadratic means that it has a degree of 2. So as long as you have an x squared, and that's the highest exponent in the equation, that means it is a quadratic function. And the functions can look as basic as this right here. It could be y equals x squared. It could also have more pieces to it, y equals x squared plus 4x plus 3, something like that. There's different formats of this equation as well. But again, the important thing is that it has a degree of 2. And the graph of this function is going to look something like this. It's going to be this U shape, and that U shape is called a parabola. So we're going to learn all about quadratic functions over the next few days, and you're going to learn why the graphs look the way that they do. You're going to eventually graph them yourself, and you're going to realize why this U shape is actually happening. But for now, let's just talk about the basic vocabulary. So, a quadratic function is a non-linear function. That just means it's not going to be a straight line. It's not going to be a constant rate of change. It's a non-linear function that has a degree of 2. So, let's write down a few different examples of what those equations might look like. Like I said, it could look as basic as this, y equals x squared. That's just a very basic quadratic function. You can also use the function notation. So something like this, f of x equals, I'm going to add some more numbers to it, 3x minus 5. That's another example of a quadratic function. We've got that degree of 2. And then I'll write one more over here. A lot of times you'll see quadratic functions that look like trinomials, if you remember that from the last chapter. Trinomials are polynomials that have 3 terms. So here's an example of that where we have 3 terms, but it still has that degree of 2. The graph of a quadratic function forms a U-shaped curve, and that curve is called a parabola. That's just the name of the shape. So parabola looks like this. It is symmetrical on both sides, so you could draw a line down the middle and it would be the same on both sides. You can also have parabolas that go upside down, and we're going to see those in this chapter for sure. Okay, so now let's talk about the basic vocabulary that we need to know. These are the key characteristics of a quadratic graph. And we're going to be using these words a lot in this chapter, so it's really important that you know what they are. So the first one is called the vertex. And the vertex of a quadratic function is this point here at the bottom. It's either going to be the lowest part of the graph, or sometimes it might be the highest part of the graph. If the graph was upside down like this, then the vertex would be the highest point of the graph. And it's going to be right in the middle. So, it's going to be the same on both sides here. That vertex is going to be right in the middle of the graph. So we're going to label that point as the vertex. And then over here, we're just going to write a little definition. So the vertex is the highest or lowest point of the graph. I'm also going to draw a couple pictures right here, just really small if you can fit them, because the vertex can also be called something else sometimes. So I'm going to draw a parabola and then I'm going to draw an upside down parabola and I'm going to label the vertex on each of these. So if the vertex is at the bottom, we also sometimes call that a minimum. That's the minimum point of the function, or min for short. Okay, and if it's on the top, we sometimes call that the maximum or max for short. And that makes sense, right? Like if it's the lowest point of the graph, it's a minimum. If it's the highest, it would be a maximum. Okay, the next term that we need to know is called the axis of symmetry, and it is just basically a line of symmetry. It's this purple dashed line right here. It's not actually part of the graph, right? Like you can't really see it on the graph, but it's this imaginary line that goes right down the middle of the function. So basically just a vertical line that cuts it in half. So we're going to label that on the picture. This is the axis of symmetry. And as for the definition, I will say it is the vertical line that cuts the graph in half. And it always will pass through the vertex too. That's important. So it always passes through vertex. Another really important thing about the axis of symmetry, and we're going to talk about this more on the next page, because it is a line, it actually has an equation. So if I were to ask you what the axis of symmetry is for this graph, you would write it as an equation. And if you remember from in the beginning of the year, vertical lines have equations that look like this. X equals, and it's going to be wherever it crosses the x-axis, which in this case would be 3. So x equals 3, that's the equation of this line right here. So that equation is the axis of symmetry. On the next page, you're going to be asked to find the axis of symmetry, and this is how you should be writing it. You should always be writing it as an equation, x equals 3. Okay, and these last two points here on the graph, these blue ones, these are called roots. So the roots of a quadratic are the points where it crosses the x-axis. So this is a root and this is a root. Many times quadratic functions are going to have two roots, and that's because it has this U-shaped curve, right? It's going to cross the graph in two places. Not always, and you'll see examples where that doesn't happen, but most of the time it's going to have two roots. So over here, we will say that roots are the point or points where the graph crosses the x-axis. These are often called many different names, and I'm going to write a few of those down here as well. Sometimes we call these the x-intercepts, which makes sense, right? We've called them that before. X-intercepts is just where it crosses the x-axis. They're also called the zeros. We actually talked about that a long time ago when we talked about functions. And we also call them the solutions. And we will talk more about why that is in a few sections later. Okay, so go ahead and turn the page when you're ready. Okay, the next thing we're going to talk about is when the quadratic function is increasing versus decreasing. So quadratic functions are interesting because they're unlike the other functions that we've worked with so far. When we talked about linear functions and exponential functions, they were either increasing like this, right? There's a linear example, here's an exponential example. Those are both examples of increasing because they're going up over time, or they were decreasing. So they could be going down like this, and then an exponential would look something like this. Okay, so it was very clear whether it was increasing or decreasing. Now, with a quadratic function, they actually increase and decrease. So they will increase on one side and they will decrease on one side. So both things are happening on the same function. So if you look at this picture, this graph, if you follow the curve from left to right, it's going down on this side, so that's decreasing. And then once it hits that vertex, it changes directions, and now it's going up. So it's decreasing on the left side and increasing on the right side. We're going to practice more with that in this first example down here. Okay, so in this example, we are being asked to identify all of the following characteristics of this quadratic function. So it's really just practicing this vocabulary, making sure we know what all of these things are. So let's do that. The vertex is, remember, that highest or that lowest point. So in this example, it would be this point right here at the bottom. And when you write out the vertex, you just want to write it as an ordered pair. So the coordinates of this point are +4, -5 on the y-axis. So we're going to write that as an ordered pair. So the vertex is at 4, -5. And then it says, is it a max or a min? It's definitely a min because it is the lowest part of the graph. If it were, upside down, then we would say it would be a max. Okay, that axis of symmetry. So remember, axis of symmetry is the line that goes down the middle. And if I draw that line, it would be right here. And it looks like it's crossing that x-axis at 4. Now, here's the most common mistake that I see is a lot of people just want to put 4, but that's not how we write the axis of symmetry. Remember, this is a line, so when you're writing down what it is, it needs to be an equation because lines have equations. And the equation is always going to look like this, x equals 4. That's because vertical lines, that's how the equations always look. It's always x equals 4 because that line is fixated on that x-axis at 4. Okay, the next one is roots. And in this example, we have two roots. So the roots are here and here. It's just where it crosses the x-axis. So we have one, it looks like at 7, and then we have one at +1. And there's a couple way to write roots. Some people just put 1 and 7, and I'm okay with that. Or you could write them as ordered pairs, 1, 0, and 7, 0. Okay, either one is fine with me. All right, let's talk about domain and range. So we've covered these vocabulary words quite a bit throughout this school year. Domain means all of the possible inputs or x values, and range is all the possible y values. So let's take a look at this graph and try to figure that out. So one thing to keep in mind is that this U shape is going to extend forever. And it's going to keep getting wider and wider at the top. So it's going to go out kind of like this, which means our domain is not restricted at all. You could go anywhere on this x-axis and you are eventually going to hit this graph. If I go to 10, I'm going to hit the graph up here. If I go to -50, if I keep going all the way up, I would eventually hit this graph somewhere. So that means that my domain is everything. We can call that all real numbers. X could be any real number on the x-axis. Now the range is not quite everything. It's definitely a lot of numbers, but it's not everything. So the lowest part of this graph is right here where that vertex is, and that is at -5 on the y-axis. That's the lowest that it can go. And then once we go up like this, the graph doesn't ever stop. So the highest that it could go, well, there's no restrictions there. So here's how we're going to write our range. The y values have to be more than or equal to 5. So y is greater than or equal to 5. That would make sense because all the y values are either at -5 or higher. Okay, and these last two questions, it says, when is it increasing and when is it decreasing? So here's how we're going to answer those. We want to look at the graph and we want to decide on what side of the graph is it going up and on what side of the graph is it going down. I'm going to erase these marks here so we can look at this a little closer. Okay, so if we're looking at this function, that line down the middle, remember it was right here at 4. And this graph is increasing on the right side. That's when the graph is going up. So remember, just think of it as kind of like a roller coaster. You're going left to right, it's going down, 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 and then it's going up, 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 up. So on the right side, this would be the increasing side. And here's how you're going to answer the question. It is increasing to the right of this 4, right? Which is on the x-axis. So we're going to say that the graph is increasing when x is more than 4. And that's because if I go back to this graph Any of the x values that are beyond 4, that's going to be on this right-hand side here, and that's the side that's increasing. It's decreasing on the left side. So it's going down like this on the left. So we're going to say it's decreasing when x is less than 4. So that's how we always respond to these types of questions here. It's always based off of that x-axis number where that line of symmetry is, and it's increasing on the right, decreasing on the left. Sometimes that will be the other way around. It depends on what the graph looks like. We'll see that in the next example, but this is how I want you to write the answers for those. Okay, so example 2, same thing here. This time we have a parabola that is upside down. So let's go ahead and look at all the vocab words here and try to write all of these out. So the vertex is this highest point. The coordinates of that are 1 and -1. And this time it is a max because it's the highest point of the graph. The axis of symmetry is this line right here down the middle, and that line is crossing the x-axis at 1. So we're going to say it is x equals 1. Okay, the roots. So the roots are where this graph crosses the x-axis. But if you look at that x-axis, it actually never does. So this one has no roots. We're going to say none. That will happen sometimes. So most of the time it's going to cross, in two spots, but in this case, it doesn't cross at all. That's because this graph is going upside down. So the domain and range now, the domain is still going to be all real numbers here because again, that x-axis is not restricted. If you go to, +10, it's going to hit down here somewhere. If you go to -100, it's still going to hit down here somewhere. So the domain would be everything. And then the range, the highest point of this graph is right here at that vertex, which is at -1 on the y-axis. But this time the graph goes down forever instead of going up forever. So we're going to say that the range is y is less than -1. So we're using less than instead of greater than because it's going down. Oh, I'm sorry, less than or equal to. It definitely has the equal to line under it because it can be equal to -1. All right, and then finally, when is it increasing? When is it decreasing? So in this example, it is increasing and decreasing on the opposite sides as it was before. So as you can see, it's going up on the left. And that's left of this -1 spot right here on the x. So we're going to say it's increasing when x is less than -1. And that's because if we're at -1 and we go backwards like this, that's the side that it's increasing on. And then it's decreasing on the other side of it. So we can say it's decreasing when x is greater than -1. Okay, let's go ahead and turn the page. There are a couple examples that you're going to try yourself. So at this point, you can pause the video and you're going to try these two on your own. And then when you're ready, you can unpause the video and check your answers. Okay, so here are the answers to the two you try problems, and I'm going to walk through some of this for each one of these. So in that first one, the vertex is right here at -1, 1, and that's a min. The axis of symmetry is at x equals -1. Remember, always write those as an equation. You don't want to put -1, you want to put x equals -1. This one has no roots because the graph is not touching the x-axis. Don't get confused by this y-axis. Some people want to call that a root. That's not a root. Roots are x-intercepts only. The domain's all real numbers again. The range is going to be greater than or equal to +1 because the lowest part of that graph is at +1 on the y-axis, and then it continues to go up from there forever. So we would say greater than or equal to. And then it is increasing on the right-hand side of the line. So if you look at this line here, it's increasing on the right side. That means that x has to be greater than -1 because it's to the right of it. And that's how we want to write it. We want to write x is greater than -1. And then it's decreasing on the left side. So that would be when x is less than -1. All right, second example, same thing. Vertex is up here. That's at 3, 4. This time it's a max because it's the highest point. Axis of symmetry is at -3. The roots, it does have roots this time. It's at 1 and +5. Domain, again, is all real numbers. The range should be less than or equal to this time because the graph is going down. So that highest point is 4, and then it's going down from there. So it should be less than or equal to 4. And then this time, the increasing and decreasing is kind of swapped from the last one. It is increasing on the left side, which would be our less than symbol. X is less than 3. And it is decreasing on the right side, which would be greater than 3. Okay, so now we are going to practice doing some very basic sketches of a parabola. Eventually, we're going to learn how to graph quadratic functions the right way. We're gonna graph them super accurately using a lot of points. But for right now, we're just going to do some basic sketches just to get the basic idea down of how this looks. So in our first example, it's telling us to sketch the quadratic function that has a maximum at 2, 3. Now remember what that maximum means. It means that if the graph is going to look something like this, it means it's going to have to be upside down because in order to be a maximum, that vertex has to be the high point of the graph, which means it needs to look like this. So far we know that our vertex is going to be at 2, 3 and the graph is going to go down kind of like this. And then it also has roots at 0 and 4. So let's just plot the things that we know. We know the vertex is 2, 3. I'm going to put a dot right there. And then we know it has roots at 0 and 4. Remember, these always go on the x-axis. So I'm going to put one of them at 0 and one of them at 4. And then we're just going to kind of sketch a parabola that goes upside down through those points. Doesn't have to be perfect. Again, we're going to learn how to graph these more accurately. But for right now, this is okay. We've got our maximum at 2, 3, and then we've got our roots at 0 and 4. Okay, next one, same thing. This one has a vertex also at 2, 3, but this time it says minimum. So that means the graph is going to go like this because we want that point to be the low point of the graph. So let's put our dot there. There's 2, 3. Now notice it says no roots. That means it should not cross the x-axis. So we don't want to draw it upside down because if we draw it upside down, it would cross the x-axis. So instead, we're just going to draw it up like this. That would be an example of a quadratic that has a minimum at 2, 3 and no roots. It would have to open up like this. Okay, that is it for the notes today. Those are the basics about quadratic functions. And as we go through this chapter, we're just going to continue learning more about these functions and how to graph them and how to work with them. But for right now, you can start on the homework.